Hi everyone, can you hear me well? Yes. So, great. So I'd like to talk about XPen, which is a new library that we are developing at Zalando. And it's all about the statistical analysis of A/B tests. So a few questions. Who of you has worked with A/B testing before? Okay, that's great, because our library is really convenient for users, and who has worked on developing tools for A/B testing? Okay, just a few, so this is really great. We are open source. Maybe you have something to contribute, and we would love to see that. So yeah, but let me first tell you a little bit about my story. So I'm with Zalando only for 3 months now, so I'm pretty new. And before that, I've been a research assistant working on the analysis of brain activity and brain-computer interfaces. So what researchers are concerned about is the brain and how it works. And it's really like there's a lot of complex behavior there, and nobody really understands how it works. And what researchers do is they do experiments. And these experiments are like, we invite people to our lab, glue electrodes on their heads, and measure brain activity when we expose them to an experiment that we've designed for a given hypothesis. So this is usually done with a very small number of subjects we have, because it's super time-consuming and yeah, costly, therefore. But after measuring these brain activity, we do statistical analysis of that, and that's the exciting part. And because there you can really get all the insights and come up with new hypotheses to do new experiments. So this is scientific experimentation, and we can pretty much transfer that to the business world. So we want to do experiments there, but we are not really interested in how the brain works, but a lot of what we are doing is about our customers and about how we can do our services as best as possible to fit their needs. So we want to gain insights from their complex behavior. So they are really super diverse, and a lot of things play into that, like emotions and things like that. So we want to do experimentation. And we are in a fantastic situation here, because we can easily expose things that we want to try in experiments to a lot of people. So this is really great from a statistical point of view, because we get great statistical validity, but also these results have some real-world meaning, and we can expect that the things that we are trying and experimenting are really working out in the real world. So again, this is the statistical analysis is really the exciting part, and because here we can get new insights and drive our processes to build better and better projects or products. So we come up with new hypotheses from what we've learned, and this can be a lot of different stuff here. So of course, typical A/B testing is changing the front end, for example, the color of a button in an app, or but it can also be something like a back-end algorithm. And the XPen that I want to talk about now is all about this statistical analysis of these tests or experiments that we are doing. And yeah, there you can use that with all different kinds of experiments. So the XPen library is a library for statistical analysis of these randomly controlled trials. And you can use that for A/B testing and multivariate testing. And it supports all different kinds of metrics that you want to include in these analyses like categorical variables and continuous variables and things like that. And it's open source now, released under the MIT license and available on GitHub and written in Python. So what is Xplan not? It's not a complete A/B testing framework. So it's not about the assignment of the different entities like the customers to the different variants. And it's also not about how you get your business data in for the analysis. I think for the first point, for the random assignment, there are nice projects on GitHub. I did a little bit of research about that, and I think they would greatly work together with Xplan. And for the data retrieval process, you might want to have your custom developed processes there just to retrieve your business relevant metrics. So I'd like to talk about 3 parts of the library. That's the experiment object. That's the most important thing for the user to interact, where you can do all the analysis from that. And I will go into a bit of a detail on what goes into this experiment object and how you can use it. Then I will talk about the analyses, and in the end show you our result structure and what you get out of that. So to create an experiment object, you need 3 kinds of ingredients. It's metadata, features, and key performance indicators. And I will go shortly into a bit of details about that. So metadata is quite simple key value pairs that give you additional information about the experiment. So this is very simple, but it's very important as well. So to have information about the experiment ID, the experiment names, the different data sources involved, different units, timings, and things like that, and that you want to store together with the data to be able to make good analyses. The second thing is features, and this is all about properties of the entities that you're investigating. So, for example, demographic properties about your customers that you know. Here we have, for example, this guy, and we know he is male, 35 years old, and a frequent buyer. So things like that can go into the features, and these features are don't change during the experiment, and they are therefore measured before the treatment start. And you can represent that in such a table where you have an idea of the entity here and all the features over there. And the third part is KPIs, key performance indicators, and it is the measures of the effects that you want to see. So this is about your business metrics, for example, but can also be like conversion rates. And we can have several of them, and they are typically measured, of course, after the treatment start, when this experiment runs, or afterwards, if you can retrieve them. And they also can be time resolved. So, for example, here we see we have 2 different entities here, and we can represent that KPIs in such a table. So we have the variants that were exposed. This is like a time resolution that can be in days or months or hours or whatever. And then we have some KPIs showing like revenue or whatever other metric you want to have for your analyses. So if we want to load that into Xplan, we want to create an experiment object, and this is really just a one-liner in Python code. So what we provide is the baseline variant. This is where against we do all the analysis like the existing system, for example, when we do some changes. Then the metrics, which are the KPI and the features, and the third thing is the metadata. When you execute that, you will see that some initial checks are performed, and then you most likely will get an output that says a summary of what you put in. Like here we have my fancy experiment from the metadata, which has 2 features, 4 KPIs, and the primary KPI is revenue. We have like 1 million entities here and 2 variants, where A is the baseline variant. Okay, so let me talk about the analysis we are currently providing. We have 3 different kinds of basic analysis that we currently include in the library. The first one is maybe the most common analysis when you think about A/B test. It identifies significant differences between the different variants. So what you experience when you perform such an experiment is that for 2 variants, like A and B, the red one and blue one, you will encounter a distribution of values for a KPI. So what we are interested in here is the difference between those 2. So the delta KPI, and we want to find out if this is significantly different from 0. So we have some variance, of course, in this KPI for each of the 2 variances. And we want to perform a statistical test that shows that. And we can specify then confidence thresholds there so that we can say, for example, we want a 95% certain that the observed delta is within an interval. And what comes out of that is something like this. So we have here the observed delta and a confidence interval. And if it looks like this, so the observed and the interval is way above the 0 line, then we are good. Then it's a significant difference, and the new version or variant is working better than the baseline variant, and it looks like this. Then it crosses the 0 boundary, and we cannot draw such a conclusion. So this is the basic delta, and you can do that with the experiment object just by executing the delta method. The second analysis that we provide is the trend analysis, and there we add in another dimension, which is time. So for the delta that we have, we provide a time resolution, and also, so this is how the delta progresses and the corresponding confidence interval. And we can use that for recognizing patterns in the data over time, like seasonal patterns, for example, but also recency effects or long-term effects of that, that treatment that we are doing. And the third analysis is to quantify the differential treatment effects of subgroups. So this is about digging into the data and identifying customer groups that might perform better or worse, and to have a breakdown according to the features that we also provide. And here, for example, you can see we are doing this subgroup analysis on the feature age, and it was we have a binning algorithm in our library that can split this continuous variable into chunks. So we have a young customer group here from 18 to 24 years, and we have an older group here above 24 years. And we see that for this KPI that we are investigating in this example, it works really well for the young customers, but not for the older ones. And you can use such insights, for example, to do personalization and just expose your changes or your new variant to a subgroup of your customers. So the third thing I'd like to go into is the results. And here we have a results object that is a really generic structure for all the analysis we provide currently with the experiment object. And it looks like this. It's based on a pandas data frame. There's also the metadata included, but I show here only the data frame. So we have the metrics here in the first column, and you can imagine that you can have different metrics as well. And what we can see is here we show the sample sizes. For variant A, we have 1,000. For variant B, we have 5,000. And also the variant mean result for this KPI, which is 20 and 23.5. And this makes an uplift of 3.5, and we can also show here the confidence intervals. Here is the 2.5 and 97.5 percentiles, but you can, of course, add additional percentiles to really display a distribution. So this is for the basic delta. For the subgroup analysis, you can imagine just to copy that whole table over and show that for the different subgroups. Like for age in subgroup 20 to 30, you have a similar analysis than that. And you can have that for different subgroups, of course, and you can also have that for different time points for the trend analysis. So that's basically it for the result structure. To put it in a nutshell, we have just released XPAN on GitHub as a new library for the analysis of A/B tests. We provide some standardized input-output formats so far and a basic battery of statistical analysis methods. But this is really part of Zalando's open source strategy. So this is an early release, and we want to put in a lot of more stuff, and you are more than invited to contribute. And the library currently uses parametric statistics, but also if your data is not normally distributed, you can use bootstrapping. You can use it as a human in an IPython notebook, for example, but also in a microservice. So if you want to run that in the back end, that's totally fine. And as I said, available on GitHub and PyPy. So next steps are, for example, we're working on the visualization, and we are thinking about putting some Bayesian statistics in there. And there is a lot maybe to come. So that's probably my last slide, but I also have a Python notebook that I want to show you just to get a bit more of the code. But let me first finish that up. So this is, again, the URL. If you want to reach out, I'm here at the conference, and Ji Bao is also here at the conference. So please come to us, talk to us, send us an email. And again, I'm with the company only for 3 months, so I did only a tiny bit of the work that I'm showing you here. And these people all contributed, I guess, a lot more than me. But yeah, so then I'd like to switch over to the notebook. And this is, by the way, also on GitHub. So you can just download that and walk through by yourself if you're interested. So you can also install it simply with pip install, of course. And to provide some data, so first of all, we generate some random data here to just show a few things of the library. This looks like this. So we have quite a number of metrics here. They are normally distributed and shifted and things like that. We provide the metadata as a Python dictionary. By the way, yeah, this is just a pandas data frame then. Here we have a Python dictionary. And so what we can do now is, as I've seen on the slide, if you've seen on the slide, just execute or create the experiment object. Where is it? Yep, like this. Just the baseline variant, the data and the metadata, and then we can use that for all different kinds of analytics we want to do. For example, here the delta for the KPI normal unequal variance, and it will output something like I've shown on the slide, this results table. And yeah, we can also do that with bootstrapping if we just provide the parameter assume normal is false, and then the results are in this case pretty much the same, but it takes longer. Also here is the results of the whole different kinds of metrics that we are currently have in this simulated data set. And we also have an example of the subgroup analysis here. So I guess that's it. Thank you very much for your attention. And I'm glad to answer questions.
Thank you.
Oh.
Thanks. Maybe Bio can wave his hand so that people can reach out to him after the session.
Thank you for the presentation. My question is, do you have any possibility of persisting this data, or is it just on demand when you want a report to be generated?
I'm not sure if I got the question right. So what do you mean by possibility to process this data?
Persist, like store it in a database or anything. Do you do this for like long-term analysis or something like that?
Sure, we can just store that data in files or databases wherever you want it. So it's a pandas data frame in principle and a Python dictionary. So yeah, it's really easy to have that stored.
But it's not integrated.
Yeah, it's partly integrated. So I think we can write it to file easily from pandas, for example. Yeah, but I think if you have your custom database at your business, then yeah, you want to include something that's very specific to your business, and then you want to just implement that on your own. But I guess it's pretty easy.
And maybe a second question about scalability. So what scenarios have you tried? Like how much data for how long?
Okay, very good question. So I'm with the company for a very short time, so I'm not really super experienced, but it's like we are running big tests with that currently that are on our website. And yeah, this really scales in that sense. But I think a key point is here that a lot of the data that you gather can be aggregated for these tests because you, probably depending on your experiment, don't want to include all tracking data that you have from a user on the website, for example. So maybe it's just that you want to have one event if a person converges that was exposed to experiment or not. Yeah. So this is not really usually a huge amount of data, so that scales well in these terms.
Okay, thank you.
Hello. So a quick question. Does your library contain any consistency check support? For example, if two experiments run at the same time and we think that the metrics are not, they don't affect, they're independent, but in reality, at least on websites, I don't know many experiments that are completely independent. Mm-hmm. A click can affect something else. And so are there any checks in that respect? Or some statistical methodologies that...
Yeah, as we currently include checks about the features so that the different variants are independent, for example. And we also have things planned to check if different experiments interfere with each other, but this is currently not in the library yet.
Thank you.
Any more questions?
Can I have one more then?
Oh, sure.
Okay. So one more then. Do you? There are situations where you run an experiment and the amount of change is so small that the control and the treatment they don't show any significant difference, but there is when there is this very, very small change. Mm-hmm. Is that captured by... I'm talking about trigger logging, if you know what I'm talking about. Like triggering.
Triggering.
Like it's an event that happens 0.5% of the cases, but within that 0.5% of the cases, it affects the results. So you don't see it often, but when you see it, it's significant. And I don't know if that's captured by, libraries that are generally built on...
Okay, so I'm not quite sure if I can answer that correctly, but I think we have no special mechanism currently to deal with that in the library. You can try maybe to use the subgroup analysis for that if you can really specify that as a feature when this event happens, and then you don't have to investigate your whole experiment base just to see some small effect that is only interesting for a specific subgroup. But if you have a good algorithm for that or any idea, you're more than welcome to contribute.
Thank you.
We have one more question, probably the last one for the session.
Hi, thanks for the presentation. Python has a lot of very good modules for statistical analysis and machine learning and so on. So I was curious, how much did you have to code yourself, and what libraries did you use?
Great question. I think, you can download the code, of course, and look at it. So we are using SciPy and NumPy that are really, convenient to do these things. And they also, include basic statistical tests, SciPy, for example, like chi-square tests that we are using. But the library is more like the framework around, and so that we have these data structures that we can really provide analyses specific for these A/B tests that we want to do, and this becomes then quite some code. There are a lot of things planned and also in the library that are not covered by these basic libraries that are available in Python. But we want to of course, use SciPy, NumPy stuff as much as possible, and also pandas is part of what we are using. Yeah.
Do you want to take one more question? Any more questions? All right.
Hi. You showed that the software was about analysis of the A/B tests. However, usually the analysis is also input for defining the new A/B tests. For instance, how long should a test be run, especially on your size with so much diversity? Is that something you guys do in a different framework, or could you tell me something about setting up the new A/B test for tomorrow?
Mm-hmm. Okay, yeah, so I think there are different questions. One is, of course, how to come up with new good hypotheses. And this is, something where, for example, the subgroup analysis provides some insights maybe, but they go in a lot of other things and a lot of domain knowledge just to set up the next good test. And the other question is about sample size, I guess.
Yeah, sample size, duration of the test.
Yeah, so that's another thing that's currently not completely covered with our library. We are doing that currently manually or with other tools. And but this is maybe a good thing to include in the next future.
Yeah, because the analysis framework knows so much about previous experiments, and therefore these results can give you some input about the new experiments. Mm-hmm. No. Or do you wait until it converges and then stop the test? Sometimes people just stop the test when it converges, when they like the output, and they stop.
Yeah.
Okay. Okay. Yeah. Thanks.
Do you want to rephrase your question? Thank you so much, Dominic.
Thank you very much.
Can we give...